All right, lesson 2.3, probability, part 2. So we're building off the ideas from the previous lesson. Example 1, a bag contained 4 green marbles, or balls, 3 red balls, and 2 purple balls. Jason removed 1 purple ball from the bag and did not put the ball back in the bag. He then randomly removed another ball from the bag. What is the probability that the second ball Jason removed was purple? Alright, so we got 4 green, we got 3 red, and then we have 2 purple. Alright, Alright, so he removed 1 purple ball from the bag and did not put it back. So that leaves us with how many purple balls? 1. Alright, he then randomly removed another ball from the bag. What is the probability that the second ball Jason removed was purple? Okay, so what's the desired outcome? That he chooses a purple ball. How many purple balls are in the bag now? There's 1 ball left. Out of how many? 4 plus 3 plus 1, that's 8. Okay, there's a total of 8 balls in the bag. So, probability is 1/8. That's all there is to it. Just make sure you're paying attention to all the details. Alright, part B, Mr. Gulati is holding 5 cards numbered 1 through 5. He has asked 5 students to each randomly pick a card to see who goes first in a game. Whoever picks the card numbered 5 goes first. Alright, Juanita picks first, gets the card numbered 4, and keeps the card. What is the probability that Yoko will get the card numbered 5 if she picks second? Alright, so there's 1, 2, 3, 4, and 5. Those are the numbers to choose from. So the first person to picks the number 4, so that's out. Alright, and how many cards do you have left? You have 4 cards left. So they're asking, what is the probability that the card picked the second time is a 5? Well, how many 5s are there from the 4 numbers? There's 1. Alright, how many numbers are left to choose? Or how many cards are there left to choose? There's 4. So the probability is 1/4. Done. That's all there is to it. Problems are really simple once you get the hang of it. Example 2. Anna has the letter tiles below in a bag. She reached in the bag and pulled out an S. She then put the tile back in the bag. Okay, she's putting the tile back in the bag. If Anna randomly selects a tile from the bag, what is the probability she will select an S again? Okay, if she puts the letter back in the bag, then nothing changes. It's as if she never even took a letter out of the bag. So you don't even have to worry about all this stuff here. Oops. What happened there? Okay, so don't even have to worry about all this. It's as if it never even happened. So what's the probability that she picks an S out of the bag? How many S's are there? 1, 2, 3. There are 3 S's out of how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 out of 10. Done. Alright, part B. A box contains... Alright, a box contains 4 blue crayons, 3 yellow crayons, and 2 red crayons. John randomly pulls out a yellow crayon and puts it back. What is the probability that John will randomly pull out a blue crayon on the next try? Alright, pulls out a yellow crayon and puts it back. So since he's putting it back, nothing changes. It's as if nothing even happened. So what is the probability that John will randomly pull out a blue crayon on the next try? So how many blue crayons will be in the bag? There'll be 4 blue crayons out of a total of how many crayons? 4 plus 3 plus 2, 9 crayons. So the probability is 4/9 that he chooses a blue crayon. Alright, example 3. To get home from work, Curtis must get on one of 3 highways that leave the city. He then has a choice of 4 different roads that lead to his house. In the diagram below, each letter represents a highway and each number represents a road. Okay, so we got this grid here. So you could choose highway A, B, or C, and then depending on which highway he's on, he could choose 4 different roads to get back home. If Curtis randomly chooses a route to travel home, what is the probability that he will travel highway B and road 4? Alright, so that's one possible outcome. Highway B, Road 4. How many outcomes are there altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 outcomes possible. All right, but there's only one desired outcome possible. So the probability is 1/12. The table below shows all the possible outcomes when flipping two fair coins at the same time. Okay. All right, if you flip two coins, these are all the possible outcomes. You could get a head and then a head. You could get a head, then a tail, or you could get a tail, then a head, or you could get a tail and then a tail. What is the probability of getting one tail and one head? Okay, so how many possible outcomes are there? Well, that's one outcome, that's the second outcome, that's the third outcome, and that's the fourth outcome. So there are 4 outcomes possible. How many have the desired outcome? One tail and one head. Okay, the order doesn't matter. It's just saying you need to have one tail and one head. Well, that would be this one here and this one here. So there are 2 possible desired outcomes. If we simplify this, we get 1/2. All right. So once again, probability is really simple once you get the hang of it. If you have any questions, please make sure to ask. Begin the assignment.